in the mid-1700s, there was an astronomer named Charles Messier, and he studied comets, but sometimes when he'd go out and look up, he'd catch these fuzzy images. And so he decided to categorize them and make a list so that he would never be distracted by them ever again. Thus began the Messier catalog. Hubble just today released its own album full of Messier objects taken by the Space Telescope, and we're going to talk about them here today with you. Make sure to send in your questions and we'll answer them at the end of the show, but I'm going to introduce you to some very special guests. So today we're joined by Michelle Fowler and Kevin Hartnett. Thank you both for being here today.
Hey, yes, great to be here.
All right, we're going to jump right on into it. Who is Charles Messier and why is his catalog so cool?
Well, Aaron, you just said Charles Messier was an astronomer who was active in the late 1700s, and he was really interested in finding comets. He actually found many of them over the course of his career, but there were some fuzzy little blobs in the sky that looked like comets, but he could tell that they really weren't comets because they didn't move with respect to the stars. Right. Comets appear and disappear, and they actually move with respect to the background stars, but these little fuzzy blobs stayed right where they were. So he made a catalog of basically things to avoid that weren't comets. And the thing that is a wonderful irony is what he actually had discovered were some of the most dramatic and beautiful objects in the entire universe. Right. He discovered things like dead stars, or stars being born, or what we now know are very distant galaxies. So in fact, Messier found some of the most fascinating things in the sky.
Yep. What's very interesting is the first object that we'll talk about, the Crab Nebula, he was looking actually for the return of Halley's Comet himself, which was predicted to show up in the constellation of Taurus in that period. And so he was scanning to find Halley's Comet and came across this object we're going to talk about.
So the catalog is just numbered basically in the order that Messier discovered these things. And so we're going to start with M1. And just like Kevin said, M1 is something called the Crab Nebula. So we actually have a depiction here of where the Crab Nebula is in the sky and a little bit about what it looks like. So you can see it's actually here in the constellation Taurus. It's going to be honing in on that. And as this begins to pan in, look, there's a fuzzy little thing there. And that's what he saw, and that's what he thought might be a comet. But as we pan into it even more, you see that there's wonderful dramatic structure. And what this turns out to be is an exploded star. It's what we call a supernova remnant. So there was a star long ago that exploded, and it actually spread its material over hundreds and hundreds of light years. And in the middle, there's the dead core of a star called a neutron star. Neutron stars are amazing. They have the density of Mount Everest pushed into every teaspoonful of material. And they actually rotate hundreds of times a second. And I remember that you actually knew what year the star exploded.
Yes, so historians have figured out that this is associated with the Chinese sighting of a guest star, they called it, that was visible, so bright it could be seen during the daytime, and that was 1054. So we're very sure when this star actually exploded.
Now, Kevin is an amazing amateur astronomer. He actually takes pictures of these objects with his own telescope. So should we go to some of the images that you've taken yourself?
Sure, why not? In this case, I don't have one of M1. We'll see others, but I wanted to show you both this chart and where M1 can be found. Do you see the constellation of Taurus here? This little cluster of stars called the Hyades is V-shaped, and it marks the horns of the bull of Taurus. He's up and to the right of Orion, very easily spotted in the winter sky. And you take the lower horn and look at it with a telescope, and you're sure to find M1 if you just sweep around the field of view with that star in it, because it's very close to that star named Zeta Tauri. So I want you to know that in the Hubble catalog that's been released, we have a star chart like this for every Messier that's in the catalog. So even if you don't know anything about the Messier objects, you'll know basically where to find them in the sky, what season to look for them in, what constellation they're in, and we also tell you in the album what telescope is a good one to look for this object with, and what time of the month or what month of the year you should be looking for it.
So keeping with the theme of dead stars, there's another one of my Messier objects that's one of my favorites. It's called the Ring Nebula. And so we talked about M1 being the first one. This is all the way at M57. Now, the Ring Nebula is in the constellation Lyra. And this is actually a different sort of dead star. The first one we saw exploded violently in a supernova. This star is basically gently unraveling itself into space. It was a star that was more about the mass of the sun. It's dying and actually losing shells of gas around it. And in the middle, there's the remnant of this tiny little star, which is now cooling off and basically dying. So the Ring Nebula is a beautiful, beautiful object, and you can see some of the complexity that the Hubble Space Telescope discovered when it actually took many different visuals of this Ring Nebula. So the thing that I really love about the Ring Nebula is it's not very easy to see in a telescope. You have to use a special technique to see it. So tell us a bit about your observations of the Ring Nebula and how you see an object like this.
Okay, sure, be happy to. It's one of my favorites. It's a great summer favorite for amateur astronomers. It's high in the sky, and it's fairly easy to locate in the constellation of Lyra. But as Michelle said, it's small and a little bit hard to find. And when you put in an eyepiece that has more magnification, it dims, and it gets a little tricky to see, especially the hole that's in the center. What you have to do, and this is a trick that we amateurs use, is look to the side of the object, because the edge of your eye is more sensitive to light than the center is, oddly enough. You have rods and cones in your eye, and the rods are along the edge. So at night, your peripheral vision is better than your center vision, and you can see things that move. So as a trick, we get the object in the telescope and then look to the side of the object and wiggle the telescope a little bit, and you can actually see it better when you do that. Especially the hole in the middle. It looks like a big smoke ring in the sky when you use those tricks. Now you won't see the center star because that's pretty faint, and although I took this photo with just general DSLR and a modest telescope, the camera is more sensitive than your eye, and so it can pick up on the star. You'd need probably a 14-inch telescope to see that star.
So we're going from the theme of dead stars to something now very different, and that's the birth of stars. Messier actually discovered things that represent all the different phases of the life cycles of stars. So we're going to start talking about young stars.
Yeah, and while we walk over to talk about the young stars over here, I wanted to remind everybody to continue to send in your questions. We're getting some really great ones. We're still here at Goddard Space Flight Center talking about Hubble's Messier catalog, and now we're going to be talking about dead stars. So take it away. I'll get out of your way.
Well, that's right. These are stars that are being born. The next object we're going to talk about is one of my favorites in the sky. It's like an old friend returning every time the fall sky rolls around, and that's M42. This is the Orion Nebula. And as you can see in this wonderful animation, what the Orion Nebula really is a giant cloud of dust and gas. And inside it, there are stars forming that are lighting up this cloud. And there are actually 4 very bright stars at the very heart of the nebula called the trapezium cluster. And these stars are actually larger than the sun, more massive than the sun and brighter. And the light from them is lighting up the whole area that we know of as the Orion Nebula. To me, this is one of the most beautiful images ever taken by Hubble. It's not only beautiful, but it's very dramatic when you think about this is a cloud of dust and gas, many, many hundreds of light years across. And inside it, there are dozens, if not hundreds, of new stars forming right now. So this is a beautiful object, and I have to say that the image you took of this is spectacular. I mean, you are an amazing astrophotographer. Let's take a look at what you got with this one.
Well, it is one of my better efforts, but they're all work, and I want to really communicate that taking pictures is another aspect of astronomy that's enjoyable, it has its technical challenges, but I've spent most of my life observing these things with binoculars or a telescope, and it's as much fun. It's probably more fun than trying to take pictures of them, which is just hard. So here you see an image of Orion Nebula, and I want to point out the contrast between this one and this one. It took Hubble about 500 different pointings, mosaics stitched together to form this image. Because Hubble zooms in, it has such high magnification, it zooms into a smaller part of the object. This could all fit in the field of view of my telescope. When you're looking at this object just with a telescope and not worried about taking pictures, you want to look for it beneath the 3 stars that form Orion's belt, the sheath for his sword, if you will. right in that area from a dark spot, you can see a faint cloud. And put a telescope on it, and you can see there, right there is an image of where M42 is. Again, this is on our website, so you can find these for all the Messier objects there. But you put a telescope on it, and you can see this trapezium, 4 little stars in a trapezoid shape, and enjoy the dark and light and bands of this nebula. It's truly spectacular.
Messier actually found a number of examples of young stars. In the case of the Orion Nebula, the stars are still forming in this cloud of dust and gas. But then there are other stars that are a little farther along that have actually moved out of the clouds they were born in. And in many cases, just the radiation and also the particle winds coming off these bright young stars blows away the cloud. And so the next thing we're going to is an example of a young cluster of stars. Stars that have all formed probably in the last at least tens of millions of years. It doesn't sound very young to us, but for stars that they are. And this is a cluster called the Pleiades. And the Pleiades is a wonderful thing to see in the autumn and winter sky. It always is wonderful for me because I know that wonderful, beautiful autumn sky is rolling around. These images look very different. So here's the image that you took of this young cluster of stars. And in fact, the Hubble image has so much resolution and so much focus, it's only a tiny part of your image here.
Right.
So compare the Hubble image that we have here with what you were able to see with the Pleiades.
So it's a very tiny portion. The Pleiades is a naked eye object, and it's somewhat like 3 or 4 times the size of the full moon. So it's very big on the sky. This image taken by Hubble of part of the gas and dust surrounding these stars is right in between this bright star called Meropa and these 2 little stars next to it. So it's a very, very tiny portion of the actual Pleiades. Pleiades is also known as the Seven Sisters. A lot of people mistake it for the Little Dipper because it has this dipper shape. And with your eye, you really only see 6. There's this legend of the missing Pleiad because you don't see 7. But this cluster is also known in Japan as Subaru. And so when you look at the logo on the back of a Subaru, you're looking at this star pattern. Most people don't know that. So it's a very, very beautiful cluster, and best appreciated actually in binoculars or a small telescope where you can see just these diamonds on a black background.
So we're talking about families of stars, and the type of cluster that the Pleiades is something called an open cluster. And these are stars that form relatively close to each other in one of these big clouds. But the sun was probably in a cluster like this billions of years ago. But over that time, we've been around the galaxy so many times that just the gravitational interaction between the stars has peeled off all the other members of our star cluster. We don't really know where in the sky our brother and sister stars are. So an open cluster is a family of stars that all form together. And actually, we're going to go over and talk a bit more about some different families of stars now.
Yeah, and once again, while we're walking over, I just wanted to remind everyone to keep sending in your questions. I'm getting some really, really great ones. And we're here at Goddard Space Flight Center talking about Hubble's Messier catalog. So continue sending in your questions, and I'll let you guys talk about clusters.
Thanks, Aaron.
So here's another example of an open cluster. This is M11, which is also called the Wild Duck Cluster. And as I said before, open clusters are stars that formed together relatively recently in the last millions or tens of millions of years and are slowly peeling apart over time. So this is another one that you have a very different image. Hubble is taking sort of a picture here of the heart of this cluster, and then you have a picture of the larger cluster so people can see that.
Right. Neither one of them look much like a wild duck, do they? But if you had a small telescope or a pair of binoculars and looked at this object, which is in the summer sky in the Milky Way, you will see a V-shaped grouping of stars. The brighter stars are V-shaped and reminded the early observers of a flight of ducks or geese that are characteristically, flying in a V. When I look at this, and this is one of my favorites too, you notice right away, and so did Messier. He wrote in his catalog about this, that there's a very bright star in the center of the cluster. Hard to make out here because it just gets lost with all the others. But it's very, very noticeable when you look at it for the first time in a telescope. This amazing grouping of stars and this one bright one right in the middle. Now I find this cluster is particularly fun to look at in higher magnification, and I like to use a zoom eyepiece. So I look at it at low magnification, and the stars are really tight, and then as you twist the eyepiece, it zooms in, and you see just hundreds more. It's a remarkably beautiful open cluster, and there's something like, hundreds of stars in the cluster.
That's right. Now, an open cluster can have dozens or hundreds of stars, but there are actually much larger star clusters as well. And certainly the largest ones that are in our own galaxy, the Milky Way, are called the globular clusters. And we have an absolutely spectacular picture of a globular cluster here. This is the globular cluster M15. So this is the 15th thing on the list of things that were not comets. And this is actually a cluster of stars that contains millions of stars. Now, astronomers believe that globular clusters are actually ancient clusters. They probably formed very early on in the lifetime of our galaxy. And if you think about the Milky Way galaxy, we live in a spiral galaxy that's kind of shaped like a frisbee. It's a disk of stars and gas and dust. But the globular clusters actually orbit around the entire galaxy, almost kind of like a swarm of angry bees. They're going all different directions around the Milky Way. And in fact, globular clusters were one of the first ways that we discovered our own place in the Milky Way. It turns out that we're nowhere near the center of the Milky Way. We live out in the suburbs, about 3/4 of the way out into the disk from the center. So that's a long way from the middle of the galaxy. And all of these globular clusters orbit around the center of mass of our galaxy. So astronomers a long time ago realized that most of the globular clusters were in one half of the sky, and there were fewer on the other half of the sky. And that's because we were looking from a vantage point of being very far out from the center of the galaxy. So whenever I see globular clusters, I'm really aware of the place, the role that they had in actually giving us a map as to where we are in the galaxy.
And it's really a good thing that we're not on a planet inside a globular cluster, because we wouldn't see much of the sky at all, right? Also, it would be like daytime all the time.
You just look at all of those stars packed into that little area.
Yes, so it's very good for observing that we are where we are.
So you've got another great image here.
Yeah, so this image is fun because I took it 2 nights ago, right? And I took it with a very small telescope. But it's in the constellation of Pegasus, the flying horse, which if you go out into night sky, will appear as a square. They call it the square of Pegasus, very prominent square in the sky. And I like to consider it like a baseball diamond because it's oriented that way. And this object is located off first base. So you go up to first base and there's an L-shaped string of stars. It's right at the tip of the L. Very easy to find.
Right there.
There you go. Yep.
So we've been talking about families of stars, the star clusters, and in fact the largest families of stars in the universe are the galaxies. And these are families of stars that include hundreds of billions of stars. So let's talk a bit about some of the galaxies that we're looking at.
Yeah, and actually while we walk over to the biggest screen in the room, we'll talk about the biggest objects, right? So I just wanted to remind everybody once again that we're here at Goddard. We're talking about Hubble's Messier objects. And please continue to send in your questions. We've got a ton of good ones, and I'll let you talk about galaxies now.
Sounds good, yes. Right, so we're going to end with looking at some of these beautiful spiral galaxies. And the first one we're looking at is something called the Whirlpool Galaxy, which is known as M51. And the Whirlpool Galaxy is a spiral galaxy about half the size of our own Milky Way, and it's actually at a distance of about 23 million light years away. So you can see here in this beautiful Hubble image the detail on the spiral arms of this galaxy. The dark areas are actually lanes of gas and dust where new stars are forming inside that right now. And in fact, whenever you see red areas along the spiral arm, that's active star formation. That's where young stars are still embedded in the dust, and they're actually lighting up the dust and making it glow red. It is an absolutely beautiful spiral. So the thing that's amazing about this is it actually looks quite different through a telescope. And some people might be disappointed, but I still think it's a wonderful thing to look at. So tell us a bit about what it's like to observe a beautiful galaxy like this.
Okay. I'll tell you, it's fun to glimpse these things, even if you're not seeing them particularly clearly in the night sky. There's a connection you feel with the universe by looking at the light of these things with your own eye. So just like Messier would have seen this, it was a smudge. But now you know what it really is. And that's electrifying. If you're at night searching for these things with your telescope and finding it and realizing what you're seeing, There's nothing really quite like it. So Messier would not have seen the spiral arms because you need a large telescope to do that. And his telescopes were not very good. They weren't even made of glass. The ones that we use now with mirrors, the mirrors were made out of metal back then. And we've looked at these globular clusters. In M15, Messier noted he didn't see one star in that globular cluster that we now know has millions of stars. So his view was very, very different. But this is an image I took. It took about 4 hours to lay up that image. In a second, I'll show you what one little frame looked like. But this object was not seen by Messier at the time. It's a neighboring galaxy. He only saw the very core of this, and it looked like a little blob.
So the thing is that even if if your telescope image doesn't look like this, it's still wonderful to think that the light you're looking at, even when you see a little smudge on the sky, in this case is 23 million years old. 23 million light years away means the light took that long to get to us. So when you see this beautiful galaxy as just a smudge in the sky, that light left long before there were humans on the Earth. So you mentioned you're going to show us. So this is what you might see through even a large telescope.
Yeah, well, this is taken through an 8-inch diameter telescope, and it took, I'm trying to remember now, about 3 minutes or 4 minutes to lay up this particular image. And you see you get all the light pollution, right? The sky glow in the background too. And the trick that amateurs use is to stack all these up, line them all up. And so I took, 4 hours of 3-minute exposures, and you can get software free off the web now to align them all and stack them up, and then you learn some about processing. Honestly, although I don't want you to think that you're going to see these marvelous images, the pictures like from Hubble or even my telescope, by looking through the eyepiece, it is encouraging, or it should be encouraging to you, that I've only been at astrophotography for maybe 4 years with a digital camera, and so you can learn very quickly. There's a lot of resources on the web, but start with the Hubble site. You can find out where the Messiers are in the sky and what instrument to use to look at them. And once you get more familiar with the sky, like I've done over many years, then dabble in astrophotography.
So we're going to wrap up our catalog of the Messier objects with one of the most beautiful things in the sky called the Andromeda Galaxy, and this is M31. And I have to say, Kevin, this is your image. This is absolutely spectacular. The Andromeda Galaxy is a galaxy very much like the Milky Way. It's at a distance of a little bit more than 2 million light years away. And the thing that's amazing about the Andromeda Galaxy is that edge to edge, this is as large on the sky as 3 full moons. Think about lining 3 full moons up across that galaxy. So at night when this thing is up, there's this giant galaxy actually covering a fairly large part of our sky. But the reason you don't see it is it's very faint. And in fact, Messier could only see the very, very central part of the galaxy. But there's other objects in here as well that Messier saw, and in this gorgeous image you took. So tell us about that.
Well, would that we all had eyes to see this thing in the sky, hanging there in the autumn sky, as big as 6 full moons across, right? It's just an amazingly big object, but it's faint because it's a long way away. So when you look at this in a telescope or with binoculars, in fact, you can see this object with the naked eye from a dark place. You're really only seeing the very bright core. But that's what you'll see in a scope or binoculars. Very fun to see. I remember dragging my whole family out when I was maybe 15, and it was in the winter. And I said, now that I found it, you have to see it. So it was like 20 degrees outside. Drag all my sisters out to see this thing because it's a classic. It's very spectacular. This object, Messier also found, probably within the same night that he looked at M31. This is called M32. Again, very easy to see because it's so close to M31. And it looks like a slightly out of focus star. A little harder to see is this one down here, a companion galaxy, now known as M110. And you have to use that little trick I mentioned earlier, looking to the side of M110 to see it more clearly. I like to take people out and show them Andromeda through the telescope because it's very easy to see this, a little harder to see this, and they have to really work to see M110. So it's a great learning experience.
So going to the Hubble image of Andromeda, this is something that's kind of mind-blowing. Hubble is so powerful, it can actually see the individual stars in this galaxy 2 million light years away. Now, this galaxy contains hundreds of billions of stars. And when you look at this image, there's kind of a graininess to the image, and that's real. These are all individual stars that Hubble can pick out. Now, the amazing thing is it took Hubble over 400 different pointings to stitch together this giant mosaic of Andromeda. And in fact, Hubble only had the time to image about 1/3 of the galaxy. So think about that. More than 400 Hubble images all put together in a mosaic to cover just about 1/3 of the Andromeda galaxy. So it's an amazing thing to see and an incredible Messier object. So hopefully in talking about these wonderful objects you can see in the sky, things like dead stars, stars being born, galaxies, star clusters, you might want to go out and actually look at them yourself. And this is where Kevin is the expert. He's going to talk to you a bit about what you can do to actually go out and make your own Messier catalog. So you've brought some telescopes here. Let's go over here and take a look at this.
So I should probably start here. Because from a dark sky, you can see most of the Messier objects with a good pair of binoculars. From the Washington, D.C. area, maybe a quarter of them. But if you're out in a dark spot, you can see many of these. So get yourself a star chart like this and find them, or use the star charts that are on the Hubble site, and you'll know where to look. It's good to use a set of binoculars at night that's one like this. This is a 10 by 50. 10 is the magnification. 50 is the size in millimeters of the glass up front. Most of us have 7 by 35s at home, and they're great for terrestrial viewing, looking at things in the yard or whatever. But you want a little more power, and you want to gather more light because the stars are faint. So you want this lens to be as big as you can hold steady. That's the other caveat, right? So if you get too heavy a binocular, you can't hold it steady and you won't get a very good view. So just two other representative scopes. You might be fascinated to know that the beautiful picture of Andromeda that I took and the one of the Pleiades was taken with a scope almost exactly this size. It wasn't this particular one, but I had it mounted on the back of a larger scope and a more expensive mount that was tracking the stars, because again, had to lay up these time exposures. But you can enjoy the Pleiades and the Orion Nebula and M31 all as beautiful objects in a scope this size. Our website says for each individual object, it's best seen or can be seen with a large, medium, or small telescope. This is what we mean by small, up to 3 or 4 inches. Medium would be more in the class of a 6 to say 10-inch diameter telescope. The size of the lens, again, is the size of the, it's what's collecting the light. So think of it as your eyeball. Imagine your eyeball being 8 inches wide. You collect a lot more light. And then larger scopes, which you didn't have room on set to bring in here, can be 10, 12, 16. Some amateurs have 20-inch telescopes, great big things. But they get obviously difficult to move around. Each has their own price range and pros and cons. Read up on a website that describes telescopes before buying one. And really, I recommend learning your constellations, finding the Messier objects with a binocular, and then stepping up as your interest continues. Here's a zoom eyepiece that I was mentioning before. So you just twist it and it magnifies, so you don't have to keep reaching for different eyepieces. If you do want to do that, there's many different types, and it just makes it easier. I find it easier to just zoom in. Interestingly, Charles Messier, he looked through about every telescope he could get his hands on, and they weren't very good. And they didn't have eyepieces. The eyepieces they had weren't replaceable, I should say. They were a fixed magnification. So interesting difference.
Before we go on to some questions from the audience, actually the question I have for you is, how many Messier objects have you personally seen?
Oh boy. Yeah, so I've seen just about all of them. We didn't talk about it tonight, but there's a large group of galaxies in the constellation Como Berenices off the tail of Leo and next to Virgo, where there are just literally scores of galaxies. Some of them are Messier objects, many of them are not. They didn't make his list. So I've looked at that cluster, and when you look through the field of view, you might see 2 or 3 Messier objects, but 2 or 3 that are almost as bright that he missed somehow. And so I've seen them all. I haven't cataloged them all, but I'm starting to do that afresh now. It's kind of a bucket list thing for me. If you write down the day and time and scope that you use and some details about the sky, and send that log to the Astronomical League, you can get a certificate, which is really cool. It'll say you've seen all the Messier objects. So I'm now logging them all. I've probably seen them all, but I didn't log them all.
Well, excellent. So, I think before we go, we have some time for questions.
Yeah, we do, and it seems like we have a couple Messier collection hopefuls in here. We have one question asking, what is the best kind of telescope for a beginner? While we're over here, we might as well start with the telescope questions, yeah?
Yeah, so the best answer I've heard to that question is one that you will use, okay? So it can't be too heavy, it can't be too complicated, it can't be too expensive, right, if you're just a beginner, because you want to get your feet wet, right? And realize, hey, I really can find things and enjoy them, and then move up from there. So I find ones that have this style of mount helpful. It's called azimuth and elevation, and so it's very intuitive to just swing it around and bring it up and look for your object in one of these types of telescopes. So I think this is a good choice, not maybe this big, but an azimuth elevation kind of mount on the telescope.
And then similar, we got a different question from someone else asking what are the best kind of binoculars for backyard astronomy?
Yeah, well, again, I would say shoot for something that's like a 10 by 50, like these, and not too heavy. If you get much heavier than this, they sell stands that you can put them on, but you'll want something to steady them. So I think a 10 by 50 is a pretty good size for most places.
That's always my problem. Is I love using binoculars, but it's hard to keep them steady in your hands. So people have techniques like resting your knees on your elbows on your knees and steadying
Right.
that way, or actually going up against a wall. That's one of the harder things, is learning to steady the image.
Right.
Speaking of images, maybe we'll come out here so we can see some more of these images in the background while we take a few more questions. Watch your step. Kelly wants to know, what causes new stars to move away from the cloud that they were born in?
Well, there's a lot of reasons for this. I mean, there's actually intrinsic movement of the stars, that when stars form, they actually pick up angular momentum. They begin to spin, and the clusters of stars spin in different ways too. And over time, this can actually spin some of the stars out of the cluster entirely. But the other thing to remember is that star clusters never live just by themselves. We go around the galaxy. Right now, we're actually flying around the center of the Milky Way galaxy at about 500,000 miles an hour. Good thing we don't actually feel that. Right. And as the sun moves around the galaxy, it has very gentle gravitational encounters with other stars. Over billions of years, over many passes around the galaxy, this actually spreads the cluster out. And so we've actually left probably some of our sister stars way on the other side of the galaxy. The star formed right near us, but now it's 100,000 light years away. And that's just the regular gravitational attraction of the different stars as we move through the galaxy.
Great. It seems like these clusters kind of resonated with people. Someone else wanted to know, how far away are stars in a cluster?
Oh, now that's a very interesting question. I don't have an exact number for some of the clusters that we've been showing you, but as Kevin mentioned, if you were in a globular cluster, if you were actually in a planet around a star, in the heart of a globular cluster, the night sky would be brilliantly bright. So the closest star to us is about 4 light years away. And in the heart of a globular cluster, it'd be a lot closer than that. I don't have an exact number, but I do know the night sky would look a lot different.
4 light years is actually a long way,
yeah.
Right? And so if I've read that if you considered the volume of sphere that's 4 light years in radius, in some of these globular clusters, there can be as many as 10,000 stars within that sphere. And so imagine being on a planet around one of those. It would be just dazzling.
Yeah.
And then another question, this one looks like it's specifically for Kevin. How do you deal with light pollution?
Yes, well, I cry a lot, I guess, is the answer. If you have a portable telescope, right, which some of mine are, you get to a dark spot, and that way you can just enjoy the night sky and find things easier. Taking pictures, see, is one of the strategies that I have to fight light pollution, because you can play tricks with a digital camera. Digital camera is very, very sensitive, if you've seen in these images. And so you could play these tricks about stacking up photos and processing them and get these amazing results. I live north of Washington, D.C., where it's very, very bright. And yet you can play these tricks with a digital camera. Some of the same tricks Hubble plays, actually. Taking an image and then basically covering the shutter and putting a black cover on the telescope and taking another image. You say, why would you do that? You record the noise in the camera, and then there's software that you can use to subtract off the noise. And so this is a way to fight light pollution. You subtract it off with a digital camera. Can't do that with your eye. But Hubble plays that same trick, not to fight light pollution so much, but just to get that noise that's inherent in the camera because of its thermal qualities, and subtract that out.
It's amazing to me just how much we're missing with light pollution. I mean, I think that the most beautiful sky I ever saw was when I was in Chile. I was in the Atacama Desert where there were no lights around at all. And somebody actually pointed out the Milky Way was so bright overhead, it actually was making me cry. It was so beautiful, I was getting tears in my eyes. And I actually looked down at the ground, and someone pointed out that I was casting a very, very dim shadow on the ground. But there was no moon out that night, none of the bright planets were out that night. That was actually a shadow being cast by the Milky Way. That's how bright the Milky Way can get. So, I mean, get yourself to a dark sky area if you possibly can.
Wow, that's crazy. So we got a question about Hubble specifically. How does Hubble take so many sharp images when it's moving so fast?
Pointing. I think I'm going to lead this to the Hubble operations manager. Absolutely.
That's for you, Kev.
Yes, so you don't think about it much. That would be more of a problem if the stars were closer. But they're so far away that the light that's coming anywhere near Earth is coming in parallel beams. And so, yes, Hubble's moving around the Earth, but it's still seeing these parallel beams that come from these different distant stars. If an object were closer, like the moon, you don't see many Hubble pictures of the moon, do you? See, Hubble was never designed to look at the moon. Now we've, over the years that Hubble's been operating, we now have modes that can, but they're very seldom used because you have what they call a parallax problem. The moon's too close and Hubble is moving too fast. That light beams aren't coming to you in a parallel fashion. And so the secret is the stars are so far away.
Wow, that's fascinating. So someone asked, what is the best telescope for astrophotography?
Okay.
I don't know how to answer that question. That's why I'm asking you.
There's different types of targets, right? There's what we've been calling, these ones would be classified as deep space objects, DSOs. And there's also like the moon and planets. You would want a different type of telescope to do lunar and planetary work than you would for deep sky objects. And so that's part of the answer. For deep sky objects, I think most websites that I would go to, people more experienced than I at this, would say get a medium-sized refracting telescope. That's the type that has the lens up front with fairly short focal length, and that will probably do the best for you for these things. Lots of reasons why, but those kind of telescopes can range from the $600 one that I bought to $6,000, so you kind of go with your budget too.
And so much of it appears to be in the way you process the images. I mean, like your image of Andromeda was spectacular. I mean, I remember when I first saw it, when we were rehearsing for this, I said, that's something that like the Mount Wilson telescope would have taken 100 years ago. That would have been like the best astronomical image in the world. But here you did this out of this small scope.
Yeah, there it is, right here.
And so that has to do a lot with what you do with the imagery afterwards, too.
So true, yes. The more you stack, the more signal to noise you get, and the more you learn about Photoshop and these other processing techniques, just the better you get at it. And I really consider myself a baby at it. This, again, was about a 4-hour exposure. And many, many times more than 4 hours in processing.
And you've only been doing this for about 4 years.
Yeah. Again, it's because there's so many resources online. We're bringing you the Hubble Messier catalog online with all its information. There's lots and lots of helpful resources out there about astrophotography.
The Messier catalog is such an inspiration to me because, sort of wrapping it all up again, we talked about avoiding these things that aren't comets, but instead it turns out to be the catalog of wonders. I mean, everything from dead stars to baby stars to these vast galaxies that you took a picture of. Well, in some strange way, we have Charles Messier to thank for all that, even though it wasn't what he was looking for.
Yes, he found 13 comets on his own, remarkable for the instruments he had, and operating from the center of Paris. Can you imagine it? In an observatory there. And he co-discovered 7 others with his friends. So the man found 20 comets in his lifetime. Very, very remarkable for the instruments that he had and the place that he was doing it from. Try to even discover one from the center of Paris right now. Pretty hard to do.
Yeah. Are you ready for another question?
Sure.
Alejandra wants to know, what are your favorite locations for stargazing? I guess I can ask both of you that question.
Well, I just mentioned the Atacama Desert, but that's kind of hard to get to. So, it is amazing to me how much you actually can see from a relatively dark backyard. If you can get yourself to an area with a nice clear horizon, I've seen comets through small binoculars. I've seen small telescopes where you can see the rings of Saturn. Saturn in particular is an object, obviously a lot closer to us than the Messier objects are, but this is one of the things where if you're a little disappointed by the Andromeda galaxy just being a smudge, when you see Saturn and its rings right there in front of you, and the moons of Saturn as well, that's something that just floored me the first time I saw it. It looked like somebody had taken a picture of Saturn from a textbook and just kind of pasted it on the end of the telescope. So some of these objects are actually very easy to see. They're very bright, so you don't need a dark sky to see them.
Yeah, that's right. The moon and planets, in even a very modest sized scope, can be a unforgettable experience. As you mentioned, seeing the rings of Saturn, I've been at so many star parties, we call them. We have telescopes out and have fun with the heavens. It's so fun to see people see the moon or the planet Saturn or Jupiter with its moons and bands for the first time. They never forget it. I never forgot it. That's really what got me into astronomy many, many years ago, seeing Saturn. There's a connection with the universe that you feel, and it's really unforgettable. But where would I go? Around here, I have a brother-in-law that lives down in Virginia in the mountains, and so that's a good spot to go. And the Eastern Shore is a pretty good dark spot with nice horizons, so you can see things from horizon to horizon. But if I were going to pay money and go someplace, it would probably be Chile or someplace like that, or Hawaii, to be on the top of a mountain where all the other great telescopes are, and observe from there.
And one thing I have to say is take advantage of your local amateur astronomy societies, because pretty much wherever you are in the United States, there's a local club where if you don't know what sort of telescope you'd like, if you don't know how to use a telescope, if you don't know where the nearest dark sky areas are around you, your local astronomy club will know these things.
That's right.
And they are an incredible resource. And as a professional astronomer, I would go to these large observatories and people would type the coordinates into computers, and I would make my observations. I often feel that the amateur astronomy community are the real astronomers. They're the people that really know the sky like the back of their hand.
Right. Amateur astronomy groups will also love to show you their telescopes. And so you can try before you buy if you go to a club. And that's also helpful.
Great. It's kind of like asking someone about their job, asking someone about their telescope. They can talk for days and days, right? So unfortunately, we only have time for one more question. We're going to keep answering some of your questions on Facebook as they're coming in later on, but unfortunately we only have so much camera time. So one more question. What is your favorite object you viewed through a telescope?
Oh, is that choosing between your children?
Yeah.
Oh, wow. Okay, so I guess, well, we just mentioned Saturn. So, I think that probably actually is my favorite. In the southern sky, there's something called the Carina Nebula. And the Carina Nebula is an area where you can see star birth and star death all happening at once. There are young clusters of stars. And then there's a star called Eta Carina, which is actually very close, we think, to blowing itself up in a supernova explosion. This part of the sky has these vast bands of dark dust and bright gas. And I have to say, those are some of the things that I've seen with my own eyes when I was living in the southern hemisphere that just blew me away. I mean, this is probably the closest thing I've seen with my naked eyes looking through a telescope that actually looked like a Hubble image. So Eta Carina would have to be one of my favorites.
Yeah, and for me, it is like deciding between your children, I guess. I really love to look visually at M11, that wild duck cluster, because when you first look at it in the scope, you can imagine how Messier didn't see any stars in it. They're very, very close, and yet you zoom in, and it's almost like the fly-throughs that we saw. It turns into something else, and it's in the heart of the Milky Way, where it's surrounded by hundreds and hundreds of stars to begin with. And so I don't know how to describe it. It's just beautiful. I could look at it for a long time.
If we don't know how to describe it, you need to try it yourself.
That's right.
So get out there and find the Messier catalog yourself and enjoy the absolutely beautiful images that the Hubble Space Telescope has made of these objects.
Absolutely. So like they said, if you want more, we've got the catalog up on our website, nasa.gov/Hubble. And if you want to know anything about Hubble at any time, you can follow us on Twitter at NASA Hubble. Thank you both so much for being here, and thank you all for tuning in to us, and we'll see you next time.
Hey, great to be here.
Bye.
Thank you. Bye.